Hello, I'm Krishnamurthy Pammi. We solve problems, we keep on solving problems. Problem solving is an art one must have in our day-to-day life, let it be professional life or personal life. In this session, we are going to reflect on problem solving skill and we are going to see how 7 basic quality control tools can aid problem solving. Problem solving is the key. It broadly consists of 6 steps. First, we need to define the problem. Then, we need to identify the root causes. We need to generate possible solutions, out of which we need to choose best possible solution. We need to implement the solution with commitment. And finally, we need to verify whether the implemented solution is effective or not. Defining the problem clearly becomes the heart of the art of problem solving. We are taking an example of online retail company. Our company sells its product through its portal. Now, the company has registered its revenues as 80 million in the current financial year, that is 2018, whereas its revenues were 100 million US dollars 2 years back, that is in the financial year 2016. So over the 2 year span of time, there's a dip of 20% in its revenues. Now, when it comes to net promoter score in the same period, it has observed a dip of 30%. Now, it wants to do all its possible job to ensure that it reaches its target of $120 million by 2020. That is the problem definition at hand. Look at the beauty of the problem definition. There's a dip in the revenue as well as net promoter score, and this dip is substantiated with the sufficient data and also the time frame. The organization objective of reaching 120 million revenues by 2020 is also visible. We need to define the problem in such a way that where was it, where is it, and where we want to go. Thereby, all the stakeholders will get same opinion about the problem definition. Most often in our daily scenario, we assume the problem definition, but we don't put it on paper. It's very important that we define the problem on the wall to ensure that stakeholders are of the same opinion about the problem definition. This becomes the core of problem solving. The next step is identifying the root cause. Our company prepared a sample of 1,000 customers using statistical sampling method from the population, and for those 1,000 customers, it rolled out a survey wherein it wants to gauge the customer pulse about its product across the categories mentioned here. That is extremely satisfied, satisfied, neutral, that is cannot say, dissatisfied, or extremely dissatisfied. When it receives a report, okay, it receives a running report. That means customer 1 dissatisfied, customer 2 extremely dissatisfied, customer 3 extremely dissatisfied, customer 4 cannot say. Like this, it's a running report. By looking at the running report, it is difficult to interpret or make any decisions. That's where our first QC tool called check sheet comes into picture. It is also called tally sheet. It is useful for gathering attribute data while performing inspections. In our case, our attribute is customer service rating. So across these attributes, extremely dissatisfied, dissatisfied, cannot say, satisfied, extremely satisfied, we basically count the number of responses received. So as and when we receive, we add 1 mark against the section. For example, a customer is satisfied, then I go and add 1 mark against this section. Now another person comes and says another satisfied customer, again 1 more mark. Like this, 1, 2, 3, 4, and then strike, just to make sure that 1, 2, 3, 4 and strike represents a bundle of 5, so that it's easy to count those 5s. Like this, we basically go through, scan through form by form, and then attribute wise count is allocated here. So thereby we know extremely dissatisfied is 400, dissatisfied is 300, cannot say is 100, satisfied is 150, and extremely satisfied customers are 50. So this is the count it gives across the customer service rating attribute. Now, when you put it in a histogram, it gives a beautiful meaning. Now, if you see here, I can say 400 customers are extremely dissatisfied, 300 are dissatisfied, and the height also is proportional to the number of responses received. So it gives a beautiful message, a visual message to the stakeholders. So by looking at it, the management says, oh, 70% of my customers are unhappy. It is disappointing. Yes. So it's easy to count these two blocks. Together it is coming to 700 out of 1000 people. So 70% are unhappy. So management wants to know why my people are unhappy. Can you please poll only those 70% unhappy people? Understand why they are unhappy. To know the reasons why customers are unhappy, we facilitate a workshop where we call people and learn why they are unhappy. In our case, it came out that customers are unhappy because of these 7 primary reasons. Number 1 is product on-time delivery is an issue for them. All the time they see that there is a commitment gap between the date when it is mentioned in our portal versus the shipment actually reaching them. Bad user experience on the portal is another reason. Insufficient product range, that means more number of varieties are not available for them within a given product range, whereas they are finding that in their competitor websites. Similarly, our products are highly priced. Certain times bad quality products are shipped. They experience issues with the payment channels like credit card and debit card. Whenever they pay, certain times they feel that their money is getting stuck and portal says that they have not received the payment. And finally, the product manual is not attractive and up to date. So these are the top reasons why customers are unhappy with our product. When we present these reasons to management, management says, look, it takes a long time to address all these areas or reasons. Can somebody help me? What are the top reasons, if I can address, will give me most impact? Yes, we can do that using another quality control tool called Pareto Analysis. Pareto Analysis says 80% of the problems are caused by 20% of the factors or causes. That means if we can concentrate on 20% of the factors, management can attack 80% of the problems that are impacting our customer experience. So this 80-20 rule, it helps us to select that vital few from those many useful factors we have identified in our earlier brainstorming session. What we do next is we construct a Pareto chart. That means we tabulate categories and their frequencies in descending order, and then we calculate cumulative percentage for it. Here, product on-time delivery, the frequency is 480. 480 divided by 1000 is 48%. Similarly, bad user experience is 320. 320 out of 1000 is 32%. The 32% added to 48% is coming down to 80%. Likewise, this cumulative percentage is documented here up to 100%. Now, on the left y-axis, frequency quantity, and on the x-axis, the attribute data, the category data. On the right y-axis, that means here in the right y-axis, we have cumulative percentages. Now, using this particular chart, product on-time delivery 48%. So product on-time delivery 48% here. And then second thing is bad user experience 80%, bad user experience 80% here. And then third one is insufficient product range 90%, insufficient product range 90%. Like this, we calculate or we plot the graph. And then what we do is at the 80% mark from the cumulative percentage right y-axis, we put a horizontal line, that's a green line here. And then I put, whenever it touches the curve, we put a down mark here. And now this part is what is the problem areas we have to focus. That means if we focus on these two categories or factors, that means product on-time delivery issue and bad user experience issue, if we can address 80% of customer experiencing issues can be sorted out. That's the beauty of Pareto chart or Pareto analysis. So out of the many categories, we are able to identify those 20% factors here which impact 80% of my customer experience. This is what is Pareto chart helps us. For these top priority category reasons like product on time delivery and bad user experience, these two category problems, we will take it to our team and ask, how can we address these problems? We want to generate as many ideas or as many causes possible so that we can address these two categories or problems. We'll encourage more inputs from the ground. So for example, here somebody says gaps in order fulfillment process is the problem for the product on time delivery. Okay, we note it down. Then another person comes and says lack of quality processes is the problem. Okay, we note it down. Likewise, we arrive at list of root causes for the issue called product not on time delivery. So tools unavailability, lack of infrastructure, poor training, lack of motivation, frequent power outages, late delivery from vendors. So we are asking why, and then we are getting the reasons why product on time delivery is not happening. Then we got a list of reasons. These reasons we put in this cause and effect diagram. That means our effect is unable to deliver the product on time, and under 4 heads like methods, machinery, people and materials, we arrange these why reasons. That means gaps in order fulfillment process, lack of quality process. Similarly, tools unavailability and lack of infrastructure is amounting to machinery problems. Similarly, poor training and lack of motivation is coming to people problem, and lack of late delivery from vendors and frequent power outages are on material part. So under these heads, we will identify whys and arrange them. This is called cause and effect diagram. That means these causes, by questioning why we are getting causes, these causes are actually amounting to this effect. So this is called cause and effect diagram, also called fishbone diagram. So if you see here, if you construct a fish here, like okay, you can visualize a fish like this. Okay, this is a fish like this. So you will get a fishbone diagram. Okay, so cause and effect diagram is also known as fishbone diagram, YY diagram, or Ishikawa diagram. This type of diagram breaks down the causes of the problem statements identified into discrete branches, helping to identify the main or root cause of the problem. For example, here in our earlier example, we have certain heads here. So under these heads, okay, we classified our causes. So this is also looks like a fish skeleton. That's why it's called as fishbone diagram as well. So by putting all these causes under this arrangement, okay, what are we deriving? We are actually coming up with a mathematics here saying that y is equal to function of x. What is y? Effect. Ultimate effect. Unable to deliver the product on time is the effect. And all these x's, that means these are the independent variables. Okay, x1, x2, x3, x4, x5, x6, x7, x8, all those things are amounting an effect on our unable to deliver the product on time. Now the question is, which x has more correlation with my y? That means out of all these causes, if I start addressing all these causes, time is not sufficient and within the budget I can't address it. Now tell me those x's, that means those causes that has greater amount of impact on my effect, that means unable to deliver the product on time. Okay, now using this particular thing, what we do is now we do one thing. Okay, now if we think that gaps in order fulfillment process is the parameter that we want to study and its effect or its impact on the effect unable to deliver the product on time, let us mute all other factors and do a scatter diagram. That means order fulfillment on x-axis and not on time delivery. That means the effect on y-axis. We construct a graph. That means we conduct several experiments and we try to see whether there is any correlation between these two things using statistical formula called R square. If it is nearer 1, that means it has a stronger correlation. Let us assume in our example that x1, that means order fulfillment time, has greater impact on not on time delivery by the R square coefficient. So in this example, we are now assuming that x1, that means order fulfillment time, has greater impact on y. Then I will study this x and I will try to magnify my study on the process of order fulfillment time. Similarly, we conduct this kind of exercise for all x's, okay, and prioritize those x's which we have to address. In our example, we have taken the x1 as gaps in order fulfillment process as one parameter that has more impact on y. Okay, let us proceed. Okay, now we wanted to understand the order fulfillment process in a detailed way using flowchart or a process map. In flowchart or a process map, we follow a model called SIPOC. SIPOC stands for suppliers, inputs, process, outputs, and customers. So to supplier, we provide a requirement list and they supply those requirements. When we receive the requirements, we measure whether whatever we are receiving is what we have listed the requirements or not. Now, after we receive the receivables, then we process them and we convert them into outputs. So inputs are processed into outputs. Now, these outputs are coming down as part of requirements to customers. Now, customers actually, they receive these receivables, that means outputs, and they measure it with respect to what they have ordered in the portal. So it is called SIPOC. Supplier supplies inputs to our process, we process them, we convert inputs into outputs, and these outputs are shipped to customers. So this is called SIPOC model. So our X1 is order fulfillment process. We found that that has a problem, that has higher correlation with our effect Y. That means unable to deliver on time. So we wanted to study the full process of order fulfillment. So it has receive order, prepare package, delivery, and after sales support. Okay, this is how the time is getting consumed. Now at each gate, SIPOC model, supplier, input, process, output, and customer. So for example, prepare package, receive order is my supplier, and delivery is the customer for prepare package. So whatever we have studied under SIPOC model, we wanted to analyze the process flow at each checkpoint and see whether there is any problem that is happening so that we can address it. So now what we are saying is for each cause, we are actually trying to identify what to address upon, where it is happening. Is it the problem with only one product or entire process? If there is a problem with the process, that means lot many products will get impacted. So using flowchart, we will try to understand how this X1 is getting flowed. So it's getting flown. So that flow we are understanding using the flow chart or a process map. Once we understand this, we go and study the process even further depth using the concept called control chart. The control chart says, look, my order mean time delivery, that means X bar, is 48 hours. That means on an average, we should be able to ship within 48 hours. And my process capability says that at the max, I may take 72 hours, or at the minimum, I may take 24 hours. These are called upper control limit and lower control limit. These are decided based upon the pattern you use. For example, Six Sigma methodology you can adopt to calculate these upper control limit and lower control limit. Okay, and these control limits are calculated using your process capability. Whereas upper specification limit and lower specification limit, they are specified by stakeholders. So this upper specification limit and lower specification limit are the customer expectations. These customer expectations or stakeholder expectations should be within upper control limit and lower control limit. So this UCL and LCL are derived from process. Upper control limit, that is UCL, LCL, lower control limit, they are derived from process. Upper specification limit and lower specification limit, they are derived from the stakeholder expectations. Always USL, that means upper specification limit, LSL, lower specification limit, should be within the control limit. Then only customers will be happy. If USL is beyond upper control limit, that means our process is incapable. Always there will be range of products for which customers will be unhappy. To make sure that customers are happy, USL and LSL should be within the upper control limit and lower control limit. Now, the next one is the rule of 7. That means any given point in time, above the mean, either top or bottom, 7 consecutive points should not be there. So it's proven through theory or practice that, if in case 7 consecutive points are falling on one side of the mean, then the process is incapable. So either upper specification limit and lower specification limits are falling beyond upper control limit and lower control limit, or rule of 7 applies, then our process is incapable of meeting the standards. The third one is the outliers. That means, for example, here the 80 is coming beyond our upper control limit. So this upper control 80, that means this particular product shipment which got delivered in 80 hours, it's a point of a source for us, special interest for us, so that we understand why shipment is getting delayed this many hours. So by looking at the control chart, what are we getting? We plot so many deliverables on control chart so that we can easily spot our eye on these special layers, which are either beyond upper control limit or beyond lower control limit, or we can check whether upper specification limit USL, lower specification limit LSL is within the control limits or beyond the control limits. If it is within, then process is capable. If it is beyond the control limit, that means process is not capable. And third one is the outliers. These outliers will provide a greater and significant meaning for us so that we can understand why products are getting shipped late and we can address it. So in a product company that ships 1,000 or 1 lakh products, if they plot their delivery time on control chart, our focus straight away go to the outliers. So it's easy to plot it's easy to identify those deficiencies, and they will give a greater insights to correct our process. So process capability can be understood through the control chart. So in this way, the 7 QC tools helps us in identifying the root cause. That means check sheet, histogram, Pareto analysis, fishbone diagram, scatter diagram, flow chart, and control chart. They helps insights of identifying root cause either with the product or with the process that produces the product. These tools will help us gain insights so that we can identify right root cause. We need to generate possible solutions now. Now that we have several root causes at hand, we need to come up with multiple solutions to address those root causes. This can be achieved with critical thinking. Now that we have multiple solutions at hand, we need to choose best possible solution. This can be done using control impact matrix. That means all the solutions we put down here, we segregate them into high impact solutions, medium impact solutions, and low impact solutions, and within our control solutions, not in our control solutions. That means this quadrant, solution 1 to solution 5, it signifies these are high impact solutions and which are in our control. And if they're cost effective, that means we can choose on those solutions. Now for those solutions, we need to come back with action items. So the action item tracker that says that to address this top cause, I am coming up with this action item, and here is the person who is the owner. At this periodicity, we'll review it, and this is the target closure date. This is how we convert chosen solutions into action item tracker. Now, once we have action item tracker in place, we will proceed with implementing those action items. Implementation is the key. We need to implement the actions with commitment. We do best possible planning, but if it is not followed with committed implementation by the field force, any plan is of waste. That's why implementing the solution should be performed with highest possible commitment. So some of the tools that can help the implementation is RASI matrix. For each of the action item, you have responsible, accountable, consulted, and informed. That means for action item 1 can be performed by Ramu, who is responsible, but Somu is accountable. That means if something goes wrong, Somu gets the beating. So Somu is accountable. Chandu can be consulted for this action item, and Sham can be informed. So that means using this RASI matrix, we can clearly establish the roles and responsibilities, and also we can avoid conflicts. In the absence of RASI matrix, we see that action items can slip through people and they may not achieve its destination. That's why RASI matrix helps on the field to a greater extent. After that, we need to have periodic meetings. First level at the ground, maybe twice a week. Second, with the senior, middle level management every week, and then senior management probably once in fortnight, with senior most management once in 1 month. So likewise, we have to connect the meetings output to each other. This way, the ground output is connected to the top, and top input is provided to the ground. So thereby, action items are given management commitment and team's commitment, and team works with highest possible commitment. So commitment is the key while implementing a solution. Now, after implementing the solution, we will definitely achieve results. Okay, whether the results are in line with what we have achieved or not, we have to check. And also, to gauge the customer pulse, we can conduct surveys as we have done in the step number 1. So we can reinitiate the surveys to see whether there is any change in customer pulse. So likewise, we will be going through this framework of defining the problem, identifying the root cause, generating possible solutions, choosing the best possible solution, implementing the solution, and verifying the solution effectiveness. This is the framework through which we can solve problems. So this is how the 7 quality control tools helps in identifying the right root cause. And identification of right root cause has an important role in problem solving framework. If we learn the art of problem solving framework, we become the heart of any system. That is why problem solving is the key. I appreciate your interest to learn, and I look forward to add more value add sessions in future. Thank you.